My name is Chance Hudson, and I'm a scalability engineer at the Ethereum Foundation. And today I'm going to talk to you about Zkopru. And Zkopru is an acronym for Zero Knowledge Optimistic Privacy Rollup. So this is a fairly short talk, and I'm just going to kind of dive right in. So the major feature of Zkopru is, of course, private transactions. And this hides both the sender, the receiver, as well as the amount being sent. Zkopru supports Ether, ERC20, and ERC21 tokens, and it does so with a single privacy pool. Also, because it's a rollup, it offers an order of magnitude transaction fee reduction and an order of magnitude transaction throughput, because each layer 2 block is just a layer 1 transaction. So additionally, we have this concept of viewing keys and spending keys, very similar to Zcash. So say, for instance, that you're a business using Zkopru for the private transactions, and you have different departments with different budgets, and they all have different Zkopru wallets. But you also have an accounting department that wants to sort of keep track of these other departments. You can give the viewing key to the accounting department, and they'll be able to see what is being spent, but not actually do any spending. And so this is valuable not just for businesses, but also for taxation purposes, regulation, things like this. And finally, the most valuable feature, in my opinion, is all the data is stored on-chain, and the only thing that you need to fully resynchronize is your Ethereum private key. Everything else will be reconstructed from the blockchain. So let's talk about the key derivation for Zkopru. We use the baby jub key pair, or curve, to generate key pairs, and we do so using 254 bits keys. And sort of the best case would be just using the Ethereum private key as the key for Zkopru, but most browser extensions and connectors don't allow access to the private key, and for good reason. So we had to solve this problem, and we chose to do so by generating a signed string using EIP712 and then hashing it and using that as the key for Zkopru. And so one of the big concerns we had when doing this was, how do we prevent phishing attacks? How do we prevent other websites from tricking users into just signing a random string and giving away their private key? And so as you can see right here, there's very nice standardized interfaces for EIP712, and where this message, this signature is your private key, only signed on official websites, will always be shown and is the only way to actually gain access to the key. And so this is how we generate the keys for Zkopru. So going on to deposits. Deposits are relatively cheap to include in layer 2. And this is because we use a merged hash strategy for generating deposit commits on layer 2. So each deposit sort of builds on the previous pending deposits and hashes the previous hash along with the hash of the deposit and creates this final merge deposit hash. And only that is included in layer 2. And then off-chain, you're able to verify that deposits have in fact been included, because you can take the list of deposits, hash them all together, and get the final merge deposit. So because of this, merging an arbitrary number of deposits actually costs a constant value, which is a nice feature. So how does the optimistic rollup work? We use a commitment nullifier scheme to actually spend UTXO nodes and verify the validity of UTXO nodes. So deposits create UTXOs, transactions create UTXO outputs, etc. So what you need in order to spend a UTXO? So first, you have to generate a Merkle proof showing that the UTXO exists within the UTXO tree to prove that it has in fact been created and included in layer 2. The second thing you need is a nullifier, and the nullifier corresponds to the UTXO and proves that you own the UTXO and that the UTXO has not been spent. So you have to prove that the nullifier does not exist in the nullifier tree in order to spend the funds. And the last thing you need is an ownership proof, which is typically a signature from the private key. So the trees are one part of the system, and the second part are actually the ZK snarks. So this is sort of a complicated graphic, but the main thing that I want to show is this yellow cylinder in the middle. And so the UTXO trees, or the trees in general, validate the inclusion of UTXO nodes, and the ZK snark validates that the transaction itself is valid, that the funds being spent are valid. More specifically, it proves that the inflow amount is equal to the outflow amount plus the fee. And it does so without revealing the amounts that have actually been spent, which is why it's a zero knowledge proof. So the first part, the UTXO, or the trees, validate that the nodes exist in ownership of the nodes. And the second part, the ZK snarks, validate that the amounts being spent are valid and hide the amounts being spent. So this is an optimistic rollup. So withdrawals are always kind of an issue because you have to wait typically about 7 days to allow fraud proofs to be submitted by people that are watching the chain. Zkopru is no different. We have the same 7-day waiting period, but we also have an instant withdrawal feature that allows people to offer funds in exchange for prepayment. So for instance, if I was making a 10 Ether withdrawal, I could offer 1 Ether to someone that is willing to pay me early. And this would work by the prepayer sending 9 Ether to Zkopru, and then that 9 Ether gets forwarded to me, and the prepayer assumes ownership of the withdrawal and then receives 10 Ether 7 days later. So you can think of this as short-term loans against the validity of the layer 2 state. And this isn't specific to Zkopru. Other optimistic rollups like Optimism and I think Arbitrum use similar strategies. And so I personally think this could create a very nice short-term loan market, and hopefully people can aggregate funds to fulfill these. Another thing that Zkopru has is network upgradability. We have this concept of mass migration transactions, and they use a similar strategy to deposits, except instead of depositing from layer 1 to layer 2, you're depositing from one instance of Zkopru to another instance of Zkopru. So we use the same merge strategy to create a single mass deposit, and then we send that mass deposit to the new version of Zkopru. So users can move their funds into another instance of Zkopru without having to withdraw to layer 1 and redeposit to another layer 1 contract. So finally, I want to talk about the limitations of the system. Overall, it works pretty well, but by far the largest limitation is the fact that only 4 UTXO nodes can be spent at once. So if you receive 100 transactions from 100 different people, you're going to have to send at least 25 withdrawals to withdraw all the funds. Alternatively, you could send 33 layer 2 transactions to consolidate the nodes. So first you would send 25 transactions to turn 100 nodes into 25 nodes, and then you'd send 7 transactions to turn 7 nodes or 25 nodes into 7 nodes, etc., until you have 1 withdrawal transaction. So this sort of breaks Zkopru for, like, for instance, a storefront, because they would have to be sending dozens or hundreds of layer 2 transactions if they ever want to spend the funds. This is something that we're actively researching for the next version of Zkopru, but nevertheless, it's a limitation of the current version. Another issue with Zkopru and with sort of most layer 2 applications and even crypto in general is complexity. One of the things that we have trouble with is how do we design the user interface for Zkopru in such a way that people understand? And this is something that we've done our best to solve, but this is a more general problem in the community that people and developers and designers all sort of need to pay attention to and try to collectively solve and learn from each other. That's about it, though. That's sort of the lightning overview of Zkopru. Wanted to touch on most of the major features and give a basic overview of how it works, but that's about it.